So let's get started with lab 8. Let me share the screen. So in lab 8, we will be studying about sequences. Okay. So first thing is you don't have to do anything with the MATLAB software. Okay. So when you are uploading your lab 8, you will be uploading only this PDF along with your hand calculations. Got it? So you will be doing only hand calculations for lab 8. There is no MATLAB code. Okay, you don't have to do this. Right? Okay. So before I get into the problem, let me explain you the type of questions you have for lab 8. So the first type is you need to show the sequence is decreasing, and you must also find out after which term the sequence will decrease. Okay, that is the first type of problem. And in the second type, you have a few sequence given and you need to show that the sequences are increasing. Along with that, you need to find the upper bound of each sequence. Okay. Now, coming to problem 7. Problem 7 is similar to the above problems. The only difference is here you have two sequence, okay, two different sequence, and you need to find the lower bound and upper bound for each of the sequence. Okay, just follow the questions given in the problem. Fine. Now the third type is you need to compute the limit of each and every sequence. Okay, what happens to the sequence when limit n is tending to infinity? What will be the limit L? Okay, that's what you need to find out. In the last type, you need to answer whether it is true or false. Okay, now if you say that the statement, so all these are the statements given. If you say that the statement is false, you need to give an example to prove that your statement is true. Okay, so what you're saying is true. Then you need to provide an example for that to support your answer. Got it? So if it is true, say that I'm just giving as an example, this might be a false or true, I'm not sure. So let's say that question number 13 is true. Okay, then you might not have to give a proper example, but I encourage you to do that. But remember, if you say it is true, you need to support your answer by mentioning a theorem or an idea, or if you have a lemma proposition in your textbook or in your lecture notes, you need to mention that theorem along with the statement, okay, to support your answer only if the statement is true. Fine. If it is false, then you need to give an example. If it is true, you need to mention the theorem. P for theorem. Okay. Remember in that way. Or even if you read this, you will get to know. Okay. So that is a last type of problem. Okay. I know it is a lot, but question number 13 to 18, it is, it will take you just maybe 30 minutes to complete. You just have to mention whether it is true or false. Okay. Fine. So I will be doing each example, example from each type so that you will understand how to do the rest of the problems. Now, I will not be doing the same exact problem given in your lab manual, but I will be doing a similar ones. Okay. Now, before I get into the problems, let me give you some idea about what we are doing today. Now, if you want to show the sequence is decreasing, then you need to show the inequality is true. Okay. If you show that an is greater than an plus 1, then you are done. Now, for an increasing sequence, an will be less than an plus 1. Now, what is this an? That is nothing but the sequence given in this problem. Okay, the complete sequence will be called as an. Okay. Now, what to do when they ask you to prove it is converging? Then you need to apply limit to the sequence and you need to find what happens to the sequence when limit n is tending to infinity. So when limit n tends to infinity, if that gives you a real number, okay, it might be 1, 2, 3, any number which is real or a finite number, then we say the sequence is converging. Okay, that means it also includes 0. Okay, now when I say it is diverging, that means if you apply limit to the sequence and if it is giving you infinity as the answer, then we say the sequence is diverging. Okay, also you have an example given here. Now if you consider um, this particular sequence minus 1 to the power of n, if you start from n equal to 0, okay, for n equal to 0 you get 1. Why? Because anything to the power of 0 is 1, right? Now for n equal to 1, you just have to plug in 1 here. Negative 1 to the power of 1 is negative 1, right? Now for n equal to 2, anything to the square is a positive number, so we get 1. Now if you keep on going, it will be alternating or fluctuating between plus or minus 1, right? So it never reaches a particular number, but it keeps fluctuating. Now, this example is special. Why? Because I told you that a sequence will converge if it gives you a real number, right? So here 1 and negative 1, both are real number. So we can say it is converging, but what about the definition of diverging? We say it is diverging if it is tending to infinity, right? Now, if you keep on increasing the sequence, it never reaches a specific number. So it goes on till infinity. And that's why we say this sequence is diverging. Okay, it is fluctuating, it has a real number, I agree, but if you keep on increasing, or just to say in one word, when limit n is tending to infinity, for some large number n, it will reach infinity. Okay, got it? So that's about our theory. Now let's get into the problem. I'll just give you a minute to take a note of this if you want to. Okay, let's get started with the first type. example 1. Example number 1. The first type was you need to show that the sequence is decreasing, right? So show that the sequence is decreasing. Okay, and the given sequence is this 1 divided by n plus 1. Now, as I said you in the beginning, if a sequence is decreasing, you need to satisfy this condition, an greater than an plus 1. Okay, now we know that an is 1 divided by n plus 1, right? Then what is n plus 1? N plus 1 will be n plus 1 of plus 1, right? So we get 1 divided by n plus 1 greater than 1 divided by n plus 2. Now, check whether this is true or false. Now, let us start with n equal to 0. For n equal to 0, 1 divided by 1 is greater than 1 divided by 2. Is this true or false? Of course, it is true, right? So we say that the inequality is satisfied, and this is for all positive n. Let's say 0. Okay, so this is for all positive n. Why not a negative n? That's because negative 1 plus 1 is what? 1 by 0, and that will give you infinity, right? So we don't want to reach that limit. So we will stick on to positive numbers. Okay, and not only that, if you have a negative number, then the inequality will be reversed. Okay, then you might not be able to show the sequence is decreasing nor increasing. So it will be both. And that's why we will stick on to one positive number. Okay, so this is one way of showing the sequence is decreasing, or if you want to, just in a simple way, you can start plugging in n values from 0. Okay, so let's start that. For n equal to 1, for n equal to 0, you get 1 by 1, which is 1. Now for n equal to 1, you get 1 by 2. For n equal to 2, you get 1 over 3. For n equal to 3, you get 1 over 4, and so on, right? So if you see the sequence, I mean, just look at the 4 numbers here, you'll see that it is decreasing, right? So this is 1.2, and this is 0.33, and this is 0.25, and so on, right? So the sequence is decreasing. This is a one way of showing as well. Okay, now let us move on to example number 2. So if you have any questions on the lab, on this lab, just let me know in the chat box, or you can just unmute yourself. Okay, if you want me to explain it again, let me know that as well. Okay, now let us start with example 2. You need to show the sequence is decreasing and after which term is the sequence decreasing. Now, when they ask you to show the sequence is decreasing, you have to follow the procedure which we did in the first example. Now, in question number 2, they say that the sequence is decreasing. Okay, that statement is already given. So what you need to find out is after which term will the sequence decrease. Okay, that is what you need to find out. Now, in order to find the term, you need to follow this condition. F prime of n, or let's say x, equal to 0. Oops, sorry. Less than or equal to 0. Okay. If the sequence is decreasing, the derivative of the sequence will be less than or equal to 0. Okay. Here x is nothing but n. I'm just writing it as x because that's the way we follow, right? So whenever we write a function, it will be in terms of x. So let me put that x equal to n here. Okay, do not get confused. N and x are not different, both are same. Fine. So we need to prove this now. Now, in order to do that, we have f of x equal to ln of x divided by x, right? Now, what is the derivative of this? Find out and tell me. What is the derivative of the given function? Hint is that you need to apply quotient rule. That is d by dx of u by v, u into dv by dx minus v into du by dx divided by v squared. One minus ln of x divided by x squared, right? That was quick. So that's the right answer. 1 minus ln of x divided by x squared. Okay, use the formula which I gave you here, and you will get the answer. If you want me to explain you how we got this in a detailed step, let me know. I can do that as well. Okay. Okay. And we have a condition that it has to be less than or equal to 0. Why? Because the sequence is decreasing. So the derivative has to be less than or equal to 0, right? Now we will take that information and find the value of x. Find the value of x. Okay. So 1 minus ln of x will be less than or equal to 0, because if you multiply with x square on both the side, let me write that. So we have 1 minus ln of x divided by x square less than or equal to 0. First step is multiply both sides. I just write bs as a short form for both sides. Okay, multiply both sides by x square, because we need to eliminate the denominator. So if you multiply, the numerator and denominator get cancelled. 0 into x square is 0. So we get 1 minus ln of x less than or equal to 0. Now, you need to cancel 1 as well. So multiply both sides. Multiply, subtract both sides by -1. So I get 1 minus ln of x -1 less than or equal to 0 minus 1 is minus 1. So 1 minus 1 is 0. So I'll just skip that. Now, I want you to tell me whether this is right or wrong. Do you think it is correct or do you think it is not right? Okay. So whenever you are introducing a negative sign to the inequality, the sign has to change. Okay. So whenever you are introducing a negative sign to the inequality, the sign will change. Now, this will get cancelled because you have negative on both the sides. So you get ln of x greater than or equal to 1. Now, one more question. I need to eliminate ln. So what should I multiply now? To eliminate ln, what should be multiplied? Very good. Right. It has to be multiplied with exponential function, right? So let me cancel it directly. So e into ln will give you x because they get cancelled is greater than or equal to e to the power of 1. Okay. And what is e to the power of 1? No. E to the power of 0 is 1, right? But e to the power of 1 is not 0. Yes, 2.7. So it is 2.7183, right? And this is definitely very close to 3. Agree? Because it is 2.7, so it has to be close to 3. Now, the conclusion is after, so here I told you x is nothing but n, so I'll just change the notation to n again. So this is the answer. So after third term, right? After third term, the sequence decreases. Okay, I'll give you a minute to take a note of this, and then we will proceed with example 3. Okay. Now, example 3. You have a sequence given 1 minus 1 by 4 to the power of n. The question is, show that the sequence is increasing and find its upper bound. Upper bound. Okay. Now, to show that a sequence is decreasing, I told you in the beginning, the sequence an has to be less than an plus 1. Okay. Now, what is an? An is 1 minus 1 by 4 to the power of n less than 1 minus 1 by 4 to the power of n plus 1. So you can eliminate 1 here because you have same thing on both the sides. So you get negative 1 by 4 to the power of n less than negative 1 by 4 to the power of n plus 1. Now you can shift or interchange this to make it positive. So we get 1 by 4 to the power of n plus 1 less than 1 by 4 to the power of n. And this is true for all. So the symbol which I wrote now is called as for all, positive n. And this is true, right? How can you check that? Just use n equal to 0. So you get 1 by 4 to the power of 0 plus 1 is 1 is less than 1 by 4 to the power of 0 is 1, right? So 1 by 4 is definitely less than 1, and this is true. So since the inequality is true, we say that the sequence is increasing. Okay. Now the work is to find the limit or the upper bound. So in order to find the upper bound, you have to apply limit to n tending to infinity to the sequence 1 minus 1 by 4 to the power of n. That will be equal to. Now I will keep 1 as it is. Now limit n tends to infinity for 1 by 4 is what? What is limit n tending to infinity for 1 by 4 to the power of n? Just try plugging in for different n values. Start from 0, okay? And see how the sequence is, whether the sequence is increasing or decreasing, and you will get the answer. Mm, no, it is not negative infinity. Okay. So let us start from n equal to 0. So for n equal to 0, the sequence is 1, right? And for n equal to 1, the sequence is 1 by 4. And for square, it will be 1 by 16 because 4 square is 16. 4 is 16. Now, if you keep on doing it, you get a large number in the denominator, but the numerator is 1. Now, if you want, you can try doing this in your calculator. Let's see, 9, a very, very, very large number. What do you get? You get 0. Okay, you can try doing this in your calculator. So if you divide a small number by a very large number, it will give you 0. Okay, and hence limit n tending to infinity, the sequence fraction to the power of infinity is 0, and the answer is 1. Okay, so the upper bound for the example 3 is 1. This is how you need to find the upper bound. Okay, now example number 4, we have a sequence n plus 4 to the power of 1 by 4, and you need to find its limit or find the upper bound. I will leave this example to you. You don't have to include this in the assignment. You can work on this if you wish to do that. Okay. You might have a similar problem in your lab manual. Now, here I will give you the answer for this problem is 1. Idea or hint, use exp and lan of the function. Okay, use this idea and get the answer for this problem number 4. Okay, now example number 5, I will give you a statement saying that if an is decreasing, then it has to converge. Is this statement true or false? What do you think? Is it true or false? Do you think all the sequence which is decreasing will definitely converge? Has to converge or definitely converge? Remember, convergence means you have a sequence given, and that will give you some number when you have n as a very large number. Okay, so that's the definition for, or yeah, that's the meaning of convergence. It is going to converge to a specific or a real number. So do you think all the sequence which is decreasing will converge to a specific number? So my answer is false. Okay, I say that this statement is false. Why? I will give a counter example. I will take a sequence an equal to 1 minus n square. Now the sequence is decreasing. How? Because I have 1 minus n square. When I plug in n equal to 0, I get 1. When it is 1, I get 0. And if you keep on doing it for varieties or different values of n, you get the sequence, right? Now I know the sequence is decreasing because 1 is greater than 0, 0 is greater than -1, -1 is greater than -2, and so on. The sequence is definitely decreasing, right? Now, this first statement is true. Then, will this sequence converge? Now, for the convergence, I told you need to apply a limit. Now, this will be 1 minus n square. So, anything to the, now if you have n as infinity, then n square will be infinity square, right? So definitely this is infinity. I can just write it as infinity. So 1 minus infinity, I mean, if you're just subtracting a very large number with 1, it doesn't make a difference. So I can write it as negative infinity, right? So what does this mean? Is this converging or diverging? If you get limit n tends to infinity for a sequence is infinity, then do you think it is converging or diverging? Diverging, right? This is diverging. If this helps, I mean, you can think of converging and diverging concept in this way. Okay. Now, if it is reaching negative infinity, it is going this way, right? Or if it is reaching positive infinity, it is going on the other way. Now, if a sequence is reaching a specific number or a real number, say 0, if you come from this end or if you are coming from this end, you have to reach 0. So this is like converging, right? Coming together. So converging. If you're going far away from a point, that is diverging if you're going to infinity. Got it? I mean, I guess it will help. Okay. Just I think I have completed all the problems. Now, for question number 7, as I told you, you will have two sequence given. You need to find its lower and upper bound. Okay. So in order to find the lower bound, you will apply limit n tending to 0. If you want to find upper bound, you will apply limit n tending to infinity. Okay, that's the only difference. So that's how you can complete 7A, B, C, D. Okay, so if you complete this, lab 8 will be completed. Remember, you don't have to write any MATLAB code. All you have to do for lab 8 is to submit hand calculations only. And remember, you must have all the problems. You must attempt all 18 problems. Got it? Remember, you must also provide example or a theorem for Question number 13 to 18. You just can't say whether it is true or false. You just can't say it is true, false. You need to support your answer by stating a theorem or giving an example, giving a counter example. Okay, keep that in mind. And I think this is the end of lab 8. So if you have questions on any of the lab, you can stay on Zoom or else we will meet in the next week.